We're given a quadrilateral that contains an inscribed circle. So I'm going to draw the inscribed circle to start with, and then the quadrilateral around the outside. So just get a little sketch of what's going on. Okay, the inscribed circle means that basically this is a tangent here. Okay, and I've purposely made it so it doesn't look like a square. It's actually going to look, this one is going to look like this. It doesn't matter, but I didn't want to turn it, I wanted to make it, quite general. Now we're told that the ratio of the perimeter of the quadrilateral to that of the circle is 4:3. Okay, I'm going to call the radius r. So the circumference is then going to be 2 pi r. I'm going to work in terms of r. And the answers, they actually let r equal 3. You can let it equal anything, but I'm just going to stick with the general case. And that means the perimeter of the quadrilateral, okay, it's larger and it's in the ratio 4:3. So it's going to be 2 pi r times 4/3, or divide by 3 and times by 4, which is going to give me 8 pi r/3. Okay, it doesn't actually tell me any of the side lengths or anything, but we've got this perimeter. Now we're asked to find the ratio of the area of the quadrilateral to that of the circle. So for the circle, their area is just going to be pi r squared. So how can we get the area of this quadrilateral? Well, here's the thing. If I start joining the radius to where it meets, then you see in all the cases, and here, this is the same as this, and that's the same, and that's the same. And there's a circle theorem that says when you have tangents to a point, then actually the two tangents to the point from where it meets the circle are also the same. So what we have are 4 different kites. That is the same as that. This, I'm going to do 3 of them just to show that they're not all the same. 4 here, you get the idea. I'm just going to use a dot here. I don't know, I'm making up my own notation, but I didn't want to draw 5. So lots of different kites. And that helps because actually we can work out the area of these kites, and this is going to be a right angle. That's also quite important. So I'm going to call this length here, I'm going to start labeling it. I'm going to call that A, which means that this is also A. And this can be B, which means that that is also B. And you can see I'm starting to link in the perimeter of the quadrilateral. So the quadrilateral area is going to be, well, to find the area of this triangle here, it's going to be half base times height. So it's going to be a half times A times R. But I've got another one exactly the same. So actually, this red area is simply going to be R times A. And then I can do similar up here. It's going to be a half times B times R times 2. So I've worked out that one as well. It's going to be plus RB. As I go around, this is going to be RC for similar reasons, and then RD. So if I factorize that out, it's going to be A plus B plus C plus D. Now here's the thing, this is half the perimeter. The whole perimeter is going to be 2a plus 2b plus 2c plus d. And I know the perimeter of the quadrilateral. So it's actually, I'm done. I can actually work out the area. It's going to be r times 4 pi r over 3. Or 4/3 pi r squared. Okay, well done if you got that. Like, I think this question, it looks like it's impossible when you first start doing it, but you have to recognize, these key things. Making kites, linking in the perimeter, and we're basically done because we want the area of the quadrilateral to the circle in its lowest terms. So it's going to be 4/3 pi r squared to pi r squared. I can just divide through by pi r squared, so I've got 4/3 to 1, which is the same as 4 to 3. And we're asked what 100a plus 49b is. So it's going to be 400 plus 49 times 3. That's 147. So final answer, 547. Like this question a lot.